Drones are now thought to be connected to more than 80% of the strikes that cause Russian losses on the battlefield in Ukraine. And that figure is already beginning to reshape the way modern warfare functions. In many areas of the front, a Russian tank can withstand artillery fragments, push through mined terrain, and continue operating because its heavy armor still gives the crew a real layer of protection. But if that same vehicle is detected by a reconnaissance UAV for just a few additional seconds, the whole situation can shift before the crew even realizes what is unfolding. The bigger danger is that these attacks are no longer simple one-off strikes. One drone can tear away the outer protective layer. A second drone can damage mobility and stop the target. A third drone can then strike the exact vulnerable point that has just been opened. And above the battlefield, reconnaissance UAVs keep watching the zone, ready to direct more FPV drones, bomber drones, or heavier weapons toward anything that continues to move. That is why the war in Ukraine is no longer only about drones blowing up tanks. It is increasingly about how constant surveillance, accurate strikes, and layered kill chains are rewriting the rules of survival on the modern battlefield. So how is Ukraine turning small drones into a hunting network capable of threatening tanks, radar stations, air defense assets, electronic warfare vehicles, and even Russian supply routes? And why have today's counter-drone defenses still failed to fully remove that pressure? Let's break it down with military force. Ukraine is turning FPV drones and bomber drones into a precise layer of battlefield firepower, and this layer is now reaching much farther than the trench line itself. Tanks, armored vehicles, radar positions, air defense systems, and logistics corridors are being watched from the air, then attacked when their movement creates the right opportunity. These drones do not need the destructive power of a missile to influence the battle. They need the right angle, the right timing, and a target that has been observed long enough to reveal a weakness. This is why FPV drones have become so dangerous across several sectors of the front. A small explosive payload may appear limited on paper, but the drone carrying it can move in ways that artillery shells and anti-tank missiles cannot. It can slip in from behind a tree line, dive from above, curve around a shelter, or pursue a vehicle as it tries to escape. That freedom of movement gives the operator a chance to hit areas that heavier weapons often fail to reach, especially when Russian vehicles are moving, hiding, or firing from covered positions. Reconnaissance UAVs are the starting point of this system. They monitor roads, tree lines, firing points, temporary shelters, and routes in the rear, turning every movement into targeting information. Once a Russian vehicle is located, the battlefield no longer looks like open ground. It becomes a tracked space, constantly monitored from above. The most important moment often arrives when the target slows down. A tank turning toward cover, an armored vehicle losing speed near a road, or a truck separating from a convoy can create the brief window a drone pilot needs. In that moment, the strike is not about brute force. It is about putting a small explosive charge exactly where it can produce the greatest effect. This precision gives small drones serious tactical weight. One hit can stop a vehicle, force the crew to leave it, block a route, or slow a larger assault. Even when the first strike does not destroy the target, it can disrupt the movement pattern and open the way for follow-up attacks. For Russian units, the threat begins before the explosion. It begins when a UAV sees the route, follows the vehicle, and keeps the target inside the kill chain. That is why drone warfare in Ukraine is changing how units move, hide, and choose the moment to attack. But once precision becomes the main weapon, the next question is no longer how large the drone's warhead is. The real question is where that warhead lands, because the survival of a heavy vehicle may depend on one exposed point. Open hatches have become some of the most dangerous weak spots on Russian armored vehicles. They turn heavy armor into an entrance. A tank may be designed to resist fragments, machine gun fire, and certain direct impacts, but that protection is mainly built to stop threats from the outside. When a small FPV drone gets through an open hatch, the fight changes immediately. The explosive force is no longer working against armor. It is now inside the fighting compartment. It is close to crew positions, electronics, fuel vapors, or stored ammunition. That is why a light payload can cause damage far beyond its apparent size. Tracks are another critical target because mobility is life for a tank under drone observation. A vehicle that continues moving can still turn, reverse, leave a fire zone, or disappear behind trees and buildings. Once the track is broken, that same vehicle becomes a fixed point on the map. It may still have its cannon, it may still have its armor, but it can no longer choose where the fight takes place. For Ukrainian drone teams, that changes the target from difficult to manageable. A disabled tank can be watched, circled, hit again, or passed to another weapon system. The rear of the turret and the area around the ammunition compartment become especially dangerous when exposed. Modern armored vehicles carry fuel, shells, propellant charges, rockets, and other explosive materials inside tight spaces. A small blast does not always have to defeat the strongest armor plate. It only has to start a fire in the right section, damage a cover, break a seal, or ignite something unstable. When that happens, the first explosion may be modest, but the secondary effect can be devastating. Ammunition detonation is not just damage, it is the moment when the vehicle starts destroying itself from within. This is why Ukrainian operators often aim at the vehicle's geometry instead of simply striking the center mass. A direct hit against thick frontal armor may create smoke and little else. A hit into a gap, hatch, rear corner, or lower side area can produce a completely different result. The drone does not behave like a traditional shell, flying along one fixed trajectory. It can adjust during the final seconds, follow the target, and search for the angle where the armor layout is weakest. Armored personnel carriers, MTLB carriers, and support vehicles are even more vulnerable than tanks. They often carry troops, supplies, mines, ammunition, or fuel in compartments that are not sealed like a tank turret. Rear doors, roof openings, side gaps, and cargo spaces can become entry points for a drone or a dropped munition. If the vehicle is parked under trees, hidden beside a road, or moving in a convoy, it may still look protected from the ground. From above, however, that open layout can turn into a target. The effect becomes even larger when the first vehicle in a convoy is hit. A column depends on spacing, speed, and direction. If the lead vehicle stops, catches fire, or blocks a narrow road, the vehicles behind it must respond within seconds. Some brake, some turn away, and others split off and expose their sides. That confusion gives Ukrainian UAVs more time to observe. It also gives FPV pilots more targets to choose from. What begins as one accurate strike can turn into a breakdown across the entire formation. The whole convoy can become trapped inside a watched kill zone with fewer safe choices. Ukraine is not only destroying armor, it is exploiting the design limits that every armored vehicle brings into combat. Hatches, tracks, rear compartments, ammunition areas, and convoy spacing all become weak points once the sky is watching. But as Russia adds cage armor, drone nets, and camouflage around those vulnerable areas, Ukraine has to move beyond the single perfect hit and build attacks in connected layers. Ukraine's drone tactics are becoming more dangerous because many strikes no longer rely on one perfect impact. In many cases, the first FPV drone is sent to damage the external protection around a Russian vehicle. That protection can include cage armor, drone nets, camouflage, extra plates, or improvised metal frames around the hull. These defenses are meant to catch the drone, weaken the blast, or ruin the attack angle. But once the first strike rips away part of that shield, the vehicle faces the next drone in worse condition. It is still on the battlefield, but it is no longer protected in the same way. The second FPV often becomes the real danger. After the first impact damages the outer layer, the next operator can aim at the newly exposed area. The target may still be moving, but it is often slower, disoriented, or turning toward cover. That shift in movement can give the next pilot a better chance to hit the turret area, gun mount, rear section, or another weakened point. This is why the attack feels less like a single strike and more like a sequence. Each drone creates a new condition for the drone that follows. This method also changes the value of Russian anti-drone armor. Cage armor and nets can save a vehicle from one direct hit, and they can force Ukrainian pilots to work harder. But they do not solve the problem if surveillance continues above the target. A protected vehicle that remains visible can be studied, tested, and struck again. Even a strike that fails to destroy the target can reveal where the protection bends, where it breaks, and which direction offers the easier follow-up attack. The pressure increases when the target loses mobility. Once a tank or armored personnel carrier is immobilized, the battle changes from a chase into a controlled attack. Ukrainian drone teams can wait for a better angle, send another FPV, or return later with a bomber drone. At night, bomber drones can be especially damaging because they do not need to rush. They can hover above a disabled vehicle and drop munitions until fire, secondary explosions, or structural damage make recovery impossible. This matters because survival on the battlefield is not only about avoiding destruction, it is also about avoiding abandonment. If a damaged vehicle can be pulled back, repaired, and returned to service, the loss is temporary. If drone pressure prevents recovery teams from reaching it, the vehicle becomes a permanent loss. Russia can add armor and send repair crews, but a watch-disabled target remains dangerous for anyone who approaches it. Even the recovery route can be observed before help arrives. Each drone in this layered attack can have a separate role. One strips protection, another stops movement. A third looks for the decisive angle. A reconnaissance UAV watches the result and confirms whether another strike is needed. This division of tasks gives Ukraine a way to turn small drones into a coordinated attack package without using a large missile against every target. That is the shift in this part of the war. Armor is not just being hit, it is being processed through a chain of observation, testing, damage, and confirmation. A vehicle may survive the first blast, but survival no longer means safety if it remains inside the watched zone. Once this method proves effective against tanks and APCs, the same logic can begin moving toward targets with even higher value inside Russia's wider war system, where one disabled asset can affect many connected battlefield functions. Ukraine's drone campaign is no longer focused only on armored vehicles near the front. It is increasingly reaching into the systems that allow Russia to see, jam, defend, and supply its forces. Radar stations, electronic warfare vehicles, Buk air defense launchers, fuel trains, and ammunition movements are becoming part of the same target map. This matters because modern combat power does not come from one tank or one gun. It comes from the network behind them. If that network is hit, the front line becomes slower, less protected, and harder to control. Radar and electronic warfare systems are especially valuable targets because they help Russia protect the rear area. Radar provides warning when Ukrainian drones or other aerial threats enter a sector. Electronic warfare attempts to cut the control link, confuse navigation, and make drones miss their targets. When these systems work, every Ukrainian strike becomes harder. But when drones locate and damage them, the effect can spread beyond one destroyed vehicle. A gap opens in the protective screen, and nearby Russian units become more exposed. This is why attacks on systems like Buk matter. A Buk launcher is not an ordinary truck. It is a mobile air defense platform designed to move, hide, and protect troops or equipment from aerial threats. It has more tactical value and more protection than many rear-area vehicles. A small FPV may not always destroy it with one hit, especially if the system is moving or protected by electronic warfare. But if the drone damages mobility, an antenna, the launcher section, or the crew area, the target can lose its main advantage. Once it stops, it becomes easier to follow and harder to save. The same logic applies to Russian logistics. Fuel and ammunition may not look as dramatic as tanks in a video, but they decide how long a force can continue fighting. A train carrying fuel or shells can move large quantities quickly through occupied territory. That makes it efficient, but it also makes it dangerous when tracked by drones. One accurate hit on a fuel car can start a fire. A strike near ammunition can trigger a chain reaction. The result is not only a burning rail line, it can also mean delayed deliveries, lost stockpiles, blocked routes, and greater pressure on Russian transport planning. These strikes also create a psychological and operational burden. If radar crews, air defense teams, and logistics units believe they can be watched far behind the line, they have to move more carefully. They may hide longer, change routes, reduce radio activity, or wait for safer conditions. Each small delay can weaken the tempo of a larger operation. A unit at the front may need fuel, shells, or air defense cover at a specific hour. If that support arrives late, the assault loses momentum. This is the wider meaning of Ukraine's expanding drone target list. The battlefield is no longer neatly divided between frontline combat and rear area safety. When radar, electronic warfare, air defense, and logistics are repeatedly hit, pressure spreads across Russia's whole battlefield system. But not every high-value target can be destroyed by a small FPV alone. That is why Ukraine has to connect drones with heavier layers of firepower when the target demands more force at the decisive moment. Some battlefield targets are too hard, too protected, or too valuable for a standard FPV drone to destroy on its own. A small warhead can damage armor, break exposed equipment, or stop movement. But it may not be enough against a hardened radar site, a protected electronic warfare vehicle, or an air defense system positioned under cover. This is where the reconnaissance UAV becomes even more important. It does not simply find the target. It keeps the target inside the battle picture until a stronger weapon can be used. A reconnaissance UAV can watch the same area for a long time and turn a moving target into a fixed problem for Russian forces. It can follow a vehicle as it enters a tree line, confirm whether the crew is still active, and track any attempt to reposition. More importantly, it can pass coordinates to rocket artillery or other strike units with greater destructive power. In this kind of operation, the drone is not the final weapon. It is the eye that makes the final weapon accurate. Rocket artillery becomes valuable when the target is protected against small drone attacks, but not built to survive a heavier blast. A powerful electronic warfare station may be designed to jam incoming drones. An air defense position may be covered by camouflage and supported by nearby troops. A radar vehicle may be parked carefully to reduce exposure. But once its location is confirmed and tracked, the problem changes. The target no longer has to be destroyed by an FPV at close range. It can be hit by rockets carrying far more explosive force. Heavier drones can also enter the operation after smaller drones have shaped the target. If an FPV stops a vehicle, damages its mobility, or forces it to remain in a watched area, a larger strike drone or bomber drone can be sent later. This is especially important at night, when recovery is harder and visibility from the ground is weaker. The larger drone can attack with a heavier charge, drop repeated munitions, or finish a target that survived the first stage. The important change is the division of labor. A reconnaissance UAV finds and follows. An FPV tests, damages, or stops. A bomber drone attacks slowly when the target cannot escape. Rocket artillery delivers the heavy blow when the target is too strong for light payloads. Together, these tools create a battlefield system, not a set of unrelated strikes. For Russia, this creates a deeper problem. A vehicle or system does not need to be destroyed immediately to be in danger. It only needs to be found, fixed in place, and kept under observation until the right weapon arrives. That coordination forces Russian units to adapt faster. But every new defensive layer also pushes Ukraine to build a more connected and more flexible strike cycle. This is how a small drone becomes the opening move for a larger and faster battlefield decision. Russia is adapting quickly to the growing pressure from Ukrainian drones. Cage armor, drone nets, camouflage positions, night movement, and electronic warfare systems are now appearing across many sectors of the battlefield. Russian crews understand that staying visible for too long can draw FPV attacks within minutes. As a result, vehicles often move under trees, stop near buildings, or change routes more often than before. Some units also add improvised metal structures around tanks and armored vehicles to reduce the effect of incoming drones. These defenses can sometimes reduce the damage from the first strike. A drone may hit the outer cage instead of the turret. A net may force the explosive charge to detonate earlier than planned. Electronic warfare can interrupt radio signals and make drone control more difficult in the final seconds before impact. But Russia's battlefield problem is that these measures do not fully remove the threat. They mainly force Ukrainian drone operators to adjust tactics, attack from different directions, or return with repeated strikes that test the same vehicle again. Electronic warfare remains one of the most serious threats to radio-controlled FPV drones. If the signal is blocked, delayed, or disrupted, the operator can lose control before the drone reaches the target. That is why fiber optic FPV drones are becoming more important for Ukraine. Instead of relying completely on radio communication, these drones use a physical cable connection during flight. This makes them harder to jam and allows operators to maintain stable control even inside heavily defended sectors, where ordinary FPVs may fail. Ukraine is also expanding another branch of drone warfare through high-speed interceptor drones. These systems are designed to destroy incoming Shahed drones and other Russian UAVs before they reach important targets. The goal is no longer only to strike ground vehicles. It is also to confront Russian drone operations directly in the air. The wider result is a constant race between protection and penetration. Every new defensive system creates pressure for a new attack method. Every successful strike forces changes in movement, camouflage, communication, or battlefield planning. This means the drone war is no longer just about separate explosions captured on video. It is becoming part of a larger transformation in how armies observe territory, control movement, protect logistics, and maintain battlefield awareness under permanent aerial surveillance during every phase of combat. The drone war in Ukraine shows a clear shift in modern combat. Power no longer comes only from a bigger gun, thicker armor, or a heavier missile. It also comes from constant observation, precise timing, and the ability to connect small strikes into a larger battlefield process. Ukraine is turning Russian targets into tracked objects inside a kill chain. A vehicle is seen, followed, slowed, struck, and checked again from above. That process can threaten tanks, radar systems, air defense units, electronic warfare vehicles, and logistics routes that once relied on distance or concealment for protection. Russia still has heavy equipment and deep military resources, but those advantages become weaker when movement itself can reveal danger. The next stage of this war will probably be faster, more accurate, and harder to jam. The decisive question is simple: who sees first, locks the target faster, and keeps the kill chain alive longer? Please like, subscribe, and follow the channel for more clear analysis of weapons, battlefield tactics, and the geopolitical changes shaping today's world. This content is created for educational purposes about war, peace, military technology, and the global impact of modern conflict. The goal is not to glorify violence, but to help viewers better understand how modern warfare is changing international security and human lives.